I'm kind of doing so that for the purpose of this video. See, you can see there we are passing this export. So with that, this is set. Next we are doing sys class GPIO direction, and this is this. And one thing is, it doesn't have a check. If it is activated, then we should not do that. So we need to put also some sort of check in place. If this pin is already existing, then don't do this. And here this direction also, if it is set the same, then don't do that. But for the sake of quick demo, it is fine actually. So of course we need to do that in a production code, but I am just doing a quick demo. So here what we do is init pin GPIO, and then we can pass a pin number, okay, something like that. Or it is better we just hardcode pin 11. Yeah, we can do that as well. I do like that sometimes when I code Arduino and things like that. Okay. Yep. Yeah, we can do that as well. Anyway, variables can end with numbers. Okay. So this tells it's the pin 11. Okay. Or without spaces. Okay. So pin 11 is this. And if you want, you can do also a hash define of direction as well. See, direction, okay, out in double quotes, out, define direction in and in, and you can just indent this so that it is easy to read. See, this is how I code. I thought I do some sort of a demo, so that if you are a beginner, this is how you should code. Okay, right? So we go back. See, it is quite easy to read, and it has now many lines, but still it is quite easy to read. Okay. Yes, so we do this, and let's set the direction as well. See, here we are doing this init, and we can do set direction and GPIO direction which is out. Okay, so that hash define you pass, it should take care. Okay, so let's just see. Hope it compiles. Okay, gcc -o led underscore c led c.c. okay. Yep. Set GPIO to few arguments. Yes, we are not passing the pin number. Okay, so we can do that over here. Insert pin 11 and then direction out. Okay, so hope it should compile. See, it's quite simple. See, this is how I code. I don't like writing any flowcharts and things like that. And if you're really a beginner, that's not the way industry works. Okay, we do code as the way we want the logic, and it's like writing a story. Okay, it goes with the flow. After a while, the code will have thousands of lines, but as you do this way, as and when the need arises, you keep adding the lines, and then you start writing the code. And this is what happens in the real production as well. Okay, so many do ask me how I need to get into programming and stuff. This is what you do. Forget the language, what language you use. Who cares about language? You just need to add, it's like a story writing. Okay, it should have some sort of a flow. Okay, yep. Yes, it looks good, and what we do is we can test it out. Okay, since I'm doing that pin initializing and other stuff, I'm not sure whether it works as a non root mode. Maybe perhaps I can check what is the permission of this file. Yeah, for root, you can see there for root and group user, it has these permissions. For others, it is not there. So I'm not sure, it may not work for non-root user. So I can just run it with root permission. So sudo led underscore c. We can try it out. And you can see there it is showing some kind of weird error. Echo that is gone through export, and then direction is also set, and that value, I think I have done some mistake. It is passing this 11, hence the driver or some error we are getting. But before that we check whether it's created. Yeah, you can see that the pin context is created by the driver, the kernel driver. Although I put the title as kernel, some may wonder why I'm not working on kernel. The thing is, as you do these things over here, it will get done in the kernel, and it's a way we hack. You do this and you understand what the characteristics of the driver, because we are discussing about the whole point is not turning on the LED. The whole point is about the whole point is about understanding the interfaces of various Linux drivers, and in this case it's a GPIO driver of Raspberry Pi. You can see there the GPIO 11 is created, and then cat direction. You can see their direction is also set, which means till here the code is working fine. We go back and we see here if there is any bug. Okay, so pin number I am passing, which is wrong order. Okay, so which should be pin state and then the pin number should be there. Hence it is showing that error, because such a file itself is not existing. Okay, hence we got the error like that. Okay, so we change this, we swap this pin state and pin number, so hopefully it should work, right? So hence it is showing directory non-existent. So someone have asked me what about in the comments, someone have asked me about the tools, debugging tools and stuff like that. I just replied to him. Yeah, he asked me about some debugging tools in kernel and stuff. So generally I don't use much of any debugging tools. I use prints as you seen here. Even if I do kernel code, most of the times I do, first of all, my coding practice itself is completely different, and I don't much like using any extensive tools. As you see here, the error itself shows that something goof up I have done here, and I do incorporate, as in when I do code, I do incorporate some debugging as much as possible, like you've seen the print statements over before, after or before each system call. Yep, you can see there we do we swap this, so we quickly compile and then we can run it. Yep, you can see there this is working. Yes, so let me zoom the camera. Yeah, you can see there it is just blinking, and hopefully you can able to see. Yes, right. So the fun thing about this is I can change this to any matrix. It should sort of work. Yeah, this is this row, right? Okay, it is over here. I still need to kind of understand what this pinouts are actually. So yeah, this is here. What about I move this resistor to a different pin? I think I need to change the corresponding pin over here. Is this the way? Okay, I'm not sure. I better revert it back. Yeah, I'm not sure. I need to still check. Okay, before yeah, you can see there what happened is I'm not sure, like you can just change this resistor. Hopefully some other LED should glow. So let me see if I select which one, it goes over there. Yep, I'm not sure, so let me just revert it back, it's fine. Okay, yes. So the thing about it is I just still not aware what is the exact pinout. I had a quick look. Okay, so hope you can see there, and moreover it is quite challenging. As you have seen, it's quite challenging. We can't put this in a single breadboard because it is blocking the entire this thing. leads over here, so I can't use this one, top one and the bottom one, so I need to use some sort of extension, and I can't even put it in this small board as well because it is even not sufficient in that small board as well. So the moment you populate this 8x8 matrix, you don't have any more provision to insert any jumper wires or resistors. Okay, so that's the challenge. So you can see that it just works like before, only the thing is we are driving this 8x8 matrix with no specific logic. It's just turning on one LED. So moving on, we can do one final thing, which is also the exact question my student asked, because two things I thought of covering in this episode is little bit refining the code. I don't mind if my videos take time, because of course it is fun to do these things. I do get fun when I do code. Other than that, what happens is hope you also learned something as a part of it. Okay, see, now the code looks more professional. We can go ahead and little bit we can clean these parts. We can delete these things, right? So if you kind of cover this top part, okay, the code you see here, this looks almost identical to any professional GPIO libraries which you include. Okay, so you can see there it is completely abstracting everything. Okay, so we can just delete this unwanted stuff, and now comes to the question about using fopen and stuff. And here is where, before doing that, we need to check if this file has any length. Okay, this is quite an issue. This is the value file, so ls-lh. The value file, luckily we have some kbs of length, but as you do cat value, it's going to return this weird single byte. Hence, the standard fopen is going to have some confusion. So to address, long back I did one video episode about reading a proc file in C. Okay, so read a proc file in user space. See, this is the episode. Long back I shot. This is shot around 2018. What we do is the code I have provided, and we can see there, this is the code I published in the website. And if you see there, let me go to the right episode. Let me just go to that episode. Yeah, you can see there. Okay, C code to read a proc file. The reason it's quite important is you can't just do a basic fopen and things like that. You need to be quite careful. Because it is not going to work like a typical this thing. Of course, I'm going to link that episode. If you are interested, you can have a look. Okay, it's not straightforward. So I link this page. You can scroll down all the way and then watch this episode. Okay, so there's a lot to discuss, so I don't want to include anything which I have already discussed. Since these are not zero ending files, it is quite tricky. Hence, you can do something like this, and you can run a while loop and then do an fread and things like that. So something like that we can do that. So what we do is we can try this way of setting that file contents. So we can do that to almost all these API calls, but we can try it for the set GPIO alone for this, as a part of this episode. Okay, so what we do is yes, there is a max buff length, we don't need that, and file pointer, and this is the code, raw hexdem, that is just a debug, we don't need that, and this one read and b. Okay, yes, this is just a read. Okay, if it is setting, I think we can just like that set. So in that case, let me just write a file in C. Yeah, anyway, we are not reading the file, so I'm sorry, then you don't need this entire code, because this code is to read a proc file, so this is kind of applicable even for sysfs also. So you don't need this code because this is just to read. Our intention is not to read, we need to write. So we can open, we can do it with any standard API, something like this. See, we can take something like a reference. So this is a straightforward write, fopen, and then they are opening the file with the write permission, and then fprintf, fgetters and fprintf, and that's it. Yeah, file pointer and close. So something like this we can approach. So it's quite straightforward. So what we do is we can create an identical API. See, here let me do a cat and copy it. Since I'm unable to do a copy in the VI editor, I'm doing in this way. Okay. Yep. What you can do is you can create a second variant of that API. Okay. See, yes, paste set GPIO. Say for instance, we can call this as via, fopen something. I know this is not like that regular nomenclature, but still it is fine. So we do that anyway. We have that test buff. We don't need to do all this system and prints and stuff like that. So we just, for a while, we comment these 3 lines, right? So the file which we are supposed to open is this file, and still I need this sprintf, because the file name I need to do that. Okay, so I need to open a file pointer. So we just do that. Where is that? So yeah, file of star fp, something like that, and file pointer equal to fopen, and then we can yes, we need to do that, but we need to create that file name dynamically, because we don't have that this thing. Yes, in that case we just do this sprintf, and then we can do that fopen here. Okay, fopen, and then we can pass this test buff, and then the permission is write permission, and here we don't need this echo stuff because it's just the file name. Okay, we populate this, and we just need to pass the pin number alone, and then our string is created. Okay, and then that's the file name. See this is the test buff, and pass this is the file name we need. Since each time the file name may change depending on the pin number, okay, we need to do this way. Okay, we can't simply hard code. Okay, yes, so this should do the job. Let me check. Yes, if it is null and other stuff, we can do a quick check. So fopen, and then fp, if fp equal to null, something like that, then return. I'm not passing any return value because it is not an int or something is written, so it is just a void here. So we can pass that, and then we can populate. Okay, yes, printf, I think fp, and then %d, and then we can pass that pin number, yes, underscore pin number, something like this, and then that's it. I think fclose of fp, right? So we open the file. Let me delete this part, and this line. Yeah, I think it is, that's all to it. Fprintf, and this and this and this. Yes, that's all. Yes, so fprintf, and we populate the value. We don't need to type anything here. It's just a single byte. Okay, %d, and pass the pin number, and yeah, that's about it. Okay, so what we do is below we change this API to that API, so that we can use either of that. Okay, we can do that hack through sprintf and system call or system API, or we can do this fopen way, which exactly what my student asked. Okay, so underscore via fopen. So let me try one with fopen, one with perhaps that system call. Okay, we can see if this works. Okay, so gcc -o led c dot c argument of file star something incompatible pointer type, yeah, it's not sprintf, it should be fprintf, right? So this should be fprintf, so it's a small typo. So let's correct this and compile. Yeah, so this is why, as you can see there, the error itself is self-explanatory, and you can anyway quickly debug and correct it. Okay, it happens, you do lot of times when you add new code, you do lot of times at simple typos. Okay, so you can see there, we can run that sudo/ledc, and yeah, it works fine. You can see there the LED is blinking. Yeah, I can see in the camera. Yes, you can see there, see, it is blinking over here, right? So it works fine. Yes, so this is the main aspect of kernel, kernel interfaces. Unlike IOCTL, if you provide an interface, or unlike a character buffer, if you provide an interface via proc or sysfs, the interesting thing is you can do this way, not just C, even other languages you can do fopen, and you can access like a file. Okay, although it is not a file, there is no file. Okay, but you can access like a file. Okay, it gives that sort of a sort of abstract interface like a file. Okay, so hence you can access like a file, and then you can set the parameters and it will be passed on to the kernel. Generally kernel has this bunch of APIs like copy from user, copy to user, so it pulls this the data whatever you sent, it will get